Welcome to Neo Space. Subscribe and hit the bell icon for more cosmic discoveries. For centuries, humanity has gazed at the stars, seeking answers about our place in the universe. From ancient civilizations mapping constellations to modern astronomers peering through powerful lenses, our curiosity has always driven us to look up and wonder. Each new telescope has brought us closer, but some tools change everything. These breakthroughs have transformed our understanding, revealing new worlds and cosmic phenomena we never imagined. The James Webb Space Telescope, or JWST, is one of those game changers. It represents the next leap in our quest to explore the unknown. Launched in 2021, JWST is the most powerful space telescope ever built. A true successor to Hubble, its journey to space was a historic moment, marking a new era in astronomy. Its massive golden mirror captures infrared light, allowing us to see through cosmic dust and glimpse the universe's earliest moments. This unique ability lets us peer further back in time than ever before, unlocking secrets from the dawn of the cosmos. Positioned 1.5 million kilometers from Earth at the L2 point, JWST stays cold and shielded, perfect for detecting faint signals. This remote location ensures minimal interference, giving us the clearest view possible of the distant universe. This engineering marvel lets us study everything from star birth to the atmospheres of distant exoplanets. It's opening new chapters in our understanding of how stars and planets form and evolve. One of its most thrilling missions, analyzing exoplanet atmospheres for signs of life. By peering into these distant worlds, JWST is searching for the building blocks that could support life beyond Earth. By studying starlight filtered through these atmospheres, JWST can detect water, methane, and other molecules, potential clues to life. Each discovery brings us closer to answering age-old questions about our cosmic neighbors. With JWST, we're closer than ever to answering, are we alone in the universe? The search continues, and every observation brings us a step nearer to unraveling the greatest mystery of all. When searching for life beyond our solar system, it makes sense to start with our closest neighbor, Proxima Centauri, a faint red dwarf star just over 4 light-years away from Earth. This is the nearest star to our sun, making it a natural first stop in humanity's quest to find another world like our own. In 2016, astronomers made a groundbreaking discovery, Proxima B, a rocky planet orbiting within the so-called habitable zone of Proxima Centauri, the region around a star where temperatures could allow liquid water to exist on a planet's surface. This is a key ingredient for life as we know it. This Earth-sized world instantly became a prime target in the search for extraterrestrial life. Its size and location sparked excitement, as it could potentially have conditions similar to those on Earth, raising hopes that it might be a second home for life in the universe. But there's a catch. Proxima Centauri is a volatile red dwarf, prone to frequent and powerful stellar flares. These intense bursts of radiation could easily strip away a planet's atmosphere, making it difficult for life to survive or even for water to remain on the surface. Proxima B sits in a paradox, potentially habitable, yet possibly hostile. It could be a world teeming with oceans, or a barren scorched rock blasted by its star's fury. Is it a serene water world, with clouds and seas, or a dry, lifeless planet with no atmosphere at all? The answer remains elusive, fueling both scientific curiosity and imagination. The planet is too small and too close to its star to be seen directly with current telescopes. We know it exists only by the subtle gravitational tug it exerts on Proxima Centauri, causing the star to wobble ever so slightly. Its true nature, its atmosphere, its surface, and its potential for life remained a mystery, hidden behind the glare of its parent star and the vastness of space. To solve this cosmic puzzle, we needed a new, more powerful eye in the sky, one capable of peering deeper into the universe and analyzing distant worlds in unprecedented detail. Enter the James Webb Space Telescope, humanity's most advanced tool for exploring the secrets of exoplanets like Proxima B. With JWST's launch, astronomers finally had the tool to probe Proxima B's secrets. The plan used transit spectroscopy, analyzing starlight as Proxima B passes in front of its star. As starlight filters through the planet's atmosphere, molecules absorb specific wavelengths, creating a chemical barcode. JWST's infrared vision is perfect for detecting media, JWST infrared sensor animation showing detection of atmospheric gases on exoplanet water, methane and carbon dioxide. Key ingredients for life. Red dwarfs like Proxima Centauri emit mostly infrared light, making JWST the ideal instrument. The telescope would observe multiple transits, collecting precious photons to build a clear picture. Every observation brought us closer to understanding this nearby world. The world watched as the first data streamed back to Earth. Would Proxima B reveal signs of habitability, or something else entirely? As JWST began observing Proxima B, hopes soared. The dream find water vapor or biosignature gases, evidence that life could exist. Even detecting a thick atmosphere of carbon dioxide or nitrogen would be groundbreaking, showing rocky worlds can hold onto their air. But there was also the risk of finding nothing. No atmosphere at all, stripped away by stellar flares. Each outcome, whether hopeful or disappointing, would teach us about the challenges of habitability around red dwarfs. The search was on for a world that could transform our understanding of life's possibilities. Would Proxima B be a second Earth, or a cautionary tale? The answer lay hidden in the data. In 2025, JWST's first data on Proxima B arrived. The telescope detected a clear transit. Proxima B had an atmosphere. This alone was a major breakthrough. A rocky planet in a red dwarf's habitable zone retaining its air. Scientists eagerly analyzed the spectrum, searching for water, carbon dioxide, and methane. But the results were puzzling. The expected signatures were weak or missing. Instead, unfamiliar strong absorption lines dominated the data. The team double-checked everything. No errors. The signal was real. Proxima B's atmosphere was unlike anything seen before. The molecules absorbing starlight weren't the familiar building blocks of life. Instead, they hinted at an environment far more alien and far more hostile than anyone had imagined. The dream of a second Earth was slipping away. After months of painstaking analysis, the research team finally identified the dominant molecules swirling in Proxima B's atmosphere: sulfur dioxide and carbon disulfide. These are not the building blocks of life, but rather the harbingers of a hostile world. These toxic gases, constantly spewed by violent volcanoes, painted a vivid picture of a planet in perpetual geological chaos. The air is thick with poisonous fumes, and the ground trembles with unending eruptions. Proxima B is likely covered in countless active volcanoes, their eruptions reshaping the landscape day after day. Its sky is perpetually choked with dense yellowish clouds of sulfuric acid, blocking out much of the sunlight and creating a hellish twilight. Instead of gentle, life-giving rain, corrosive acid rains fall from above, scouring the surface and making the environment even more inhospitable. These rains dissolve rock, carving away the landscape and erasing any hope for life as we know it. The true culprit behind this devastation is tidal heating. Proxima B's close, elliptical orbit around its red dwarf star causes its interior to flex and heat up, driving relentless volcanic activity and turning the planet into a cauldron of fire and gas. Ironically, the very forces that place Proxima B in the so-called habitable zone are the same ones that make it utterly uninhabitable, a cruel twist of cosmic fate. Any water that may have once existed on the surface has almost certainly boiled away under the intense heat, or been stripped and destroyed by the planet's harsh, corrosive atmosphere, leaving behind only barren rock and toxic clouds. Proxima B isn't a cradle for life, it's a furnace, a world where fire and acid reign supreme. In this case, the so-called habitable zone is nothing more than a cosmic trap, luring us with false hope. Our closest exoplanetary neighbor is not a paradise, but a volcanic nightmare, a terrifying reminder that not all worlds are meant for life. Proxima B's true nature is a sobering reality check. For years it was our best hope for finding life nearby. Now, it's a reminder that the habitable zone is no guarantee of habitability. Red dwarfs are the most common stars, but their planets may face tidal heating and violent flares. JWST's achievement, analyzing a rocky planet's atmosphere 4 light-years away, is still monumental. This discovery forces us to refine our search, considering not just distance from a star, but geology, orbit, and stellar stability. Proxima B's lesson: the universe is full of surprises, and finding a second Earth will be harder than we imagined. But our quest is far from over. The news about Proxima B is a blow, but not the end. Science advances by learning from disappointment as much as discovery. Proxima B's story is a crucial chapter, not a conclusion. We now know to be wary of tidally heated worlds around red dwarfs. The universe is vast. Hundreds of billions of stars. countless planets. Giving up hope based on one world would be like judging the ocean by a single grain of sand. The odds still favor life elsewhere, we just have to keep searching. JWST will turn its golden eye to other promising systems, like TRAPPIST-1. Future telescopes will push the search even further. The dream lives on. The search for life continues, now with clearer eyes and renewed determination.